time to start our OpenEO platform session and the public launch event is in a Phiweek side event today. So welcome everybody to that event. In the beginning, I just want to give you a slight overview about what is the plan for the next 3 hours. In the first part, we will have 4 presentations focusing on OpenEO platform, introducing the general concept, technical backgrounds, and also first use cases that we have performed. Then there will be quite a large block focusing on technical demonstrations with a number of people showing how to use OpenEO, how to work with it, and how to access data and how to process data. Within that slot, we also have foreseen a break of 10 minutes so that everybody can a little bit refresh in between. Afterwards, we will tell you our aims in respect to user engagement. So we will have some offerings to use OpenEO platform at an early stage. Yeah, during the whole event, please post your questions in the chat. So we will come back to the questions in our dedicated questions and answers session so that we really are able to respond to your feedback. So whenever there's a question around, please post it and we will keep track on it and we will tackle it in this specific slot within the event. Yeah, and then at the very end, we will close and provide you a few steps ahead. Yeah, that's actually the plan. The first presenter is Patrick Griffiths from ESA, who is the technical officer, and will give us an overview about OpenEO platform and in general the platform landscape and also the motivation of ESA, why to support our OpenEO platform activity. Yeah, with this, I will hand over to Patrick, and yeah, Patrick, the floor is yours. I will start your presentation so that you can immediately take over. So here you are.
Thank you, Christian. So thanks a lot, and welcome everyone attending this side event and the public launch event and workshop for OpenEO platform. So we're here today in Esrin in the Magalan room, but there's the wider audience attending virtually. And thanks for giving me the opportunity to have this introductory presentation here. I would like to talk about OpenEO platform entering the European Earth observation platform landscape. And I want to address mainly 2 questions in my talk. On the one hand, why do we need Earth observation platforms? And then the second part is...
Can you speak a little bit more to the microphone, at least in the remote audience?
Thanks, Alex. Yes. Is this better? Hello? Can you hear me now?
Yeah, that's better.
Okay, thanks. So in the first part of my talk, I want to address the question, why do we need Earth observation platforms? And in the second part then, yet another Earth observation platform, really? Do we really need that? We had on Wednesday a presentation from OGC, and they mentioned that there was 74 platforms in Europe alone. So the question really is, why do we need so many? And do we really need another platform for Earth observation? So, but to start with the first question, why do we need Earth observation platforms? So of course, part of the question you all know, it is the Earth observation big data revolution. And this is just a slide showing the ESA satellite missions, which is the Earth Explorers, and then the operational Copernicus and meteorology missions. So there's currently 25 missions flying and 15, this is I think outdated. There's an unprecedented number of satellite missions acquiring data, and Copernicus especially is the biggest producer of Earth observation data in the world, with 25 terabytes acquired every day and 250 terabytes disseminated every day. And all of that, of course, at free and open data policy available to all the users around the globe. But there are more faces to this big data challenge in Earth observation. As you all know, there's the data volume aspect, but there's also a data diversity aspect, there's the data continuity aspect, there's the aspect of effectively exploiting the synergies that are offered by the different missions, and also making the data available and sharing the data in efficient ways. These are all parts of the same challenge. So what was announced already 10 or 15 years ago is that we have to move towards a new paradigm. And it was too often simplified with this one hook line, which is moving the algorithm or the user to the data. You know, the European DS initiatives were one building block to facilitating this paradigm change. But I think we have all learned and understood that this is not necessarily this simple. You know, there is more to facilitating this new paradigm where we deal with this big Earth observation data record than simply moving the algorithm or the data or the user to the data. So and this is more the scientist perspective here, but Earth observation platform should offer much more than simply moving the user or the algorithm to the data. And this is really the wish list from an Earth observation scientist perspective. So there's elements such as simplification and democratization of Earth observation. So simplifying data access, streaming of data, pixel level data access, the dynamic allocation of processing resources, compute resources, and, you know, for a data scientist, Earth observation scientist, intuitive front-end programming libraries, operator chaining, these are all things that make the work life much more efficient. And then reusable mass processing pipelines are also an important element. Then there's a whole set of features that platforms should bring for collaborating and for sharing. So sharing of user code, sharing of existing code and building blocks that can be then reused to create new workflows, exposing mature algorithms as on-demand services. Interactive development is another thing that we like to see in platforms. Ad hoc visualization of intermediate results, hosted Jupyter notebooks, deferred or lazy evaluation is a key concept that's really central to efficient Earth observation platforms, but also executable tutorials are a really nice feature. And then there's a whole set of scientific advancement that basically become possible when you do this properly. So reproducibility in Earth observation science is something that is not yet fully achieved, but we're getting there. Paper and code, so publishing not only scientific results, but also the code and the data. Transparency and innovation are other aspects. So this is overall the Earth observation platform wish list from a scientist perspective. And well, at ESA, there is this, this conceptual chart that kind of illustrates the Earth observation platform ecosystem with the data producing, data generation layer at the bottom, including the PDGS and ground segments. And then you have the resource tier above with the ICT resource providers hosting the data. And then on top of that comes this two-layer block consisting of platform services and the exploiting elements that basically use these services. And this chart is probably also already 8 years old or so. And you see here already that in the middle we have the thematic exploitation platforms, which are now slowly fading out, but then also their data cubes and the Open Earth Engine ITT that led to this current activity. So if you take this conceptual chart and you kind of map that to the current reality in Europe and beyond, then you already see that there's quite a complex landscape of Earth observation platforms. And here we're following the same kind of 3 or 4 layer diagram that we saw before. And here central, you see the two new initiatives that we're supporting from the ESA side, so the Eurodata Cube and the OpenEO platform. So now we're moving into the question, why do we need another platform? So the main reason is simply that there is still a capability gap, especially in Europe, for Earth observation cloud processing and analytics. And you know, while Europe is the leader in acquiring high-quality Earth observation data, we are kind of lagging behind in terms of the analytic capabilities and enabling cloud platforms. So there's a large fragmentation of the existing resources. There's some redundancy among the offered capabilities, and there's a lack of coordination between the Earth observation platform providers to a large extent. There's also a simple prevalence of the old virtual machine model. So in many cases, you know, the Earth observation platforms still require you to pre-specify what you actually need in terms of a virtual machine configuration. And you know, there are many examples that do that much better, where you simply have dynamic resource allocation depending on your current needs and your current processes that are running, that then also enables the scaling of the processing. There's also a prevalence of file-based storage and data access mechanisms where you still have to query databases and file storage locations, then pass lists of file paths onto other operators and algorithms, rather than having pixel-level flexibility and cloud-native data structures and effective data access mechanisms. That's what we would like to see, right? So this capability gap has kind of been driving the guiding principles for OpenEO platform. Here's one last point on this list, which is the business models and the lack of a long-term perspective. And I think that's something that we made central to this activity too, that we want to see the consortium think about the long-term perspective that goes well beyond the ESA-funded project period. So this has kind of led to these guiding principles that we are following in the implementation of OpenEO platform. And these are the following. So there's abstracting of complexity by basically providing intuitive analytics and programming libraries, dynamic resource allocation, and really putting a federated cloud architecture into reality here. Providing transparency, so this relates to transparency of source code, scientific integrity and reproducibility, but also things like clarity and prior estimation of costing, which is quite complicated and not yet there, but we are certainly working on it. Confidentiality of IPR is, of course, another aspect here. And then there's, you know, pixel to continental level scalability, which basically means that you should be able to manipulate a data set on the per pixel level, but there should also be a clear roadmap for bringing your analysis from a local test to a continental or global processing workflow. So these are the guiding principles that we have been following and are following for the implementation of OpenEO platform. And just as a background, so this is really building on European excellence, because there was the OpenEO Horizon 2020 project, which was basically finished in September 2020. And then the same month, we kicked off the OpenEO platform project here with a very diverse consortium, a very good consortium, and some partners that are in there additionally to support some of the use cases. And you might be aware of OpenEO. So we're really building on top of what was achieved in OpenEO Horizon 2020. And the objectives in this activity are really to develop a federated open infrastructure for scalable cloud-based EO processing and analytics. And the consortium is really strong in science and also cloud computing experience. We have 3 cloud environment operators that are central to the EO ecosystem in Europe, so EODC, Vito, and Synergize, and then 2 strong research partners here, URAC and the Wageningen University of Münster, and EGI, and endorsement by the Geo Secretariat. And at the bottom here, you see the results that the Horizon 2020 OpenEO project achieved with their API, where they basically addressed this situation that, you know, 8 years ago or so, a user would always have to learn a certain programming dialect to run processing on a cloud environment. And the OpenEO API basically took the role of translating all these processing requests in a generic and language agnostic way for these different platform environments. And this is really central achievement that we are building on top of here for the OpenEO platform project. But there are some things that we now need to keep in mind for the further evolution of the system, and that is that, you know, it's not only the technical parts that are important. You know, there are experts who have looked into the success of platforms in various fields, and, you know, this is a quite interesting result here that, you know, you need to think about content, technology, and community, but also relationships and culture, which, you know, depending on the environment that you're working on might have different connotations. But so these are certainly things that are now becoming more and more important for OpenEO platform. Okay, and then a final slide here on the evolution from ESA point of view. It would really be important for the widespread adoption of OpenEO platform that the system corresponds in the best possible way to real-world community requirements. So not just assumptions, but we want to have feedback from the user community to what extent this is actually useful and helping and making a difference. And today we have the workshop and public launch event here with the Phiweek, but the next important milestone then is at the Living Planet Symposium in Bonn in May, where we'll have a user consultation event. We will offer some classroom trainings and maybe organize some competitions. So we hope to see many of you there as well. So we invite you really to get involved. We have now the early adopters license package ready, and we will provide some more information on that later. And we would really encourage you to get in touch with us and tell us what you intend to use OpenEO platform for. And we are able to provide sponsoring for these early adopter packages, but we would really like to learn a little bit what you plan to use the OpenEO platform for. So with that, I close my little presentation here, and I hand back to Christian for the remainder of the presentation. Thank you very much.
Many thanks, Patrick, for setting up the scene and the environment and also the motivation why we have OpenEO platform around. And we already had a quite big and well-received keynote presentation on Wednesday given by Alexander Jakob. And nevertheless, for those who missed that presentation, I think it's just also good to provide you a few further insights towards OpenEO. And I try to give you, with this quick overview, about what OpenEO is about, what are the main concepts, and what we are thinking is the base that we will build on. Yeah, it's really also very important to stress again, we don't want to build something just on our own for users. We really want to involve users and user feedback in the development in a constant manner. So therefore, that's also why this early adapter package that Patrick already mentioned is around. So we really want to involve you all into the setup of OpenEO and also to help us steering it into the right direction. Yeah, OpenEO, as Patrick mentioned, has a history in this Horizon 2020 project, OpenEO, that was quite a big success, bringing different organizations together and think about how the future of platforms should look like and how this could be set up in a federated manner. We actually used then that knowledge gained and also the open source tools that we have developed to then respond to the OpenEO Earth Engine call that ESA brought out. And I think it was really quite a perfect match in our thoughts that we have developed in OpenEO and what we then could realize and demonstrate via this OpenEO Earth Engine call that was out. Patrick already mentioned the consortium, so I really think that we are quite well experienced, well trusted entities with quite some experience there. We have already quite a good cooperation network within the Horizon 2020 project, and based on that we continue, and we also were able to do quite quick steps ahead. Yeah, the driving concepts, Patrick mentioned that, but just to again highlight them. So simplicity, that's really something that is important. Transparency, because we want to have a lot of different platforms that take part in the federation. And in order to do so, you really need to establish transparent workflows, transparent way of handling users, a transparent way of handling billing and accounting. And therefore, it's really important to have this really here as a second pillar for the overall developments. And yeah, and from pixel to continental scalability, so we really don't want to stop at a few small pixels that can be analyzed and processed. It's really the idea to roll it out on a larger scale, on a continental scale, and even beyond, really supporting their global processing activities. Yes, the network OpenEO platform as it is presented at the moment, currently it's built on top of the federation of EDC, Terrascope, operated by Vito, and EuroDataCube within the EuroDataCube consortium. It's all put it together within OpenEO platform and offered via the ESA network of resources. And in the future, we also aim to provide it within the European Open Science Cloud, just to reach out really to further users, to further scientific communities, and to be also here open and quite wide in the user community. The roadmap, just shortly shown here, coming really from the kickoff with first use cases following on, Basically, we are now in between the second and the third use case that has to be performed. We already received a positive notification to expand the project for another year. So the timeline that you see can luckily be further extended, and also during these extensions, we are already looking forward to tackle further challenges and also further use cases and developments. Yeah, that already brings me to my end. I have now the honor to hand over to Jeroen, who is driving the technical developments, and he will provide us insight into the technical concepts of OpenEO platform. So with this, I already hand over to you, Jeroen. The floor is yours, and please go ahead.
Thank you, Christian. So I have the honor to go a little bit deeper into some technical details. We have a lot of room for demos today, so this will still be some general concepts and technical bits, but then we will dive straight into the tools and the programming APIs that we offer. So I wanted to start with this one. Because what is the platform? We already saw that it's made up of actually 3 backends, as we call them. One on EODC, one on Terrascope, and a third on CreoDIAS, which is in this release still experimental, in fact. And then those also connect to the Euro Data Cube and Sentinel Hub for additional data access. And now an important thing here is, okay, you immediately see that it's made out of 3 components. But as a user, you will not really see that. You will interact with OpenEO platform, and the platform will make sure that your requests are handled by the right backend. So simplicity is a key driver, and therefore we try to avoid that you have to see that the platform is built up out of multiple components. So even in the future, backends can be added, and the simplicity should remain the same. That is really everything below the line should be hidden. And that is when we came up with OpenEO like 2 or 3 years ago, was really the goal there as well. There is one standard, OpenEO, and that allows us to do all of this, to hide all those details. A very big thing for any platform is data. You cannot be an Earth observation platform with limited or no data, and we are happy that in this release already we have 49 collections available. It's quite a list, the Copernicus, Sentinel, Landsat, and so on, and a few upcoming ones as well. These are on the website, so everybody can explore them. But also there, we want to go a step further than other platforms, because some data collections are available in multiple backends. And what I always find annoying is that there are subtle changes between how the same data set is offered on different platforms. So we are now in the process of aligning this so that you have one name, for instance, for Sentinel-1 GRT data. And when you switch your scripts to use different backends, you do no longer need to change all these names or band names and so on. You have one common view on this Copernicus data. Of course, as far as that is possible, that the data is also actually the same, because it has to be scientifically reproducible, so that has to be ensured as well. Then if we go a little bit deeper into what the backends are, so one backend is running at EODC, and it's basically running on top of OpenDataCube. So they're working with Xarray, and the parallelization and scheduling is on one hand handled by Task, and the other hand by Airflow. There I don't have too many details today, because it would take me quite far. I can always talk like for an hour about this, but we'll keep it a bit lighter now. Then similarly on Terrascope and CreoDIAS, we have a Geotralis backend basically. Geotralis is the processing engine, but people don't see that. The users, the UDFs and so on, run inside Xarray. at the bottom, we have a Hadoop cluster running at Terrascope, and on Creodias, we will be using Kubernetes. Then there is the Euro DataCube connection. 43 collections are coming from there, and that gives us access to the full Copernicus and Landsat archives, as I said. Data is downloaded on the fly. When you make requests, we fetch the data from Euro DataCube. And for batch jobs, larger asynchronous jobs, we now are developing a caching system so that the data does not need to be downloaded again every time a user makes the request for the same data set. A very nice feature that Euro DataCube has as well is Card4L compliant backscatter for Sentinel-1 data that is also then computed for you on the fly with the parameters that you selected. An experimental one, and that's also quite interesting feature, is that we use the processing capabilities of Sentinel Hub as well. So not only just downloading data from there, but also doing part of the processing inside Sentinel Hub so that the data size is actually reduced. Then another aspect actually that was mentioned by Patrick already is that we need to be scalable. And a lot of platforms have this virtual machine model where you rent a virtual machine for some time. But here, if I look at an actual user of the platform, we see that in a certain phase, usually the development phase, the user is just doing a few requests here and there. He's not running a larger production. And then when he has an actual workflow, he enters into a phase where you're doing data production. And then you need a larger capacity. And that's what we see in this graph here. So that's also how we designed the platform, that you do not need to rent VMs, a number of VMs for a fixed time. No, the platform takes care of that for you, and you only pay for the actual usage. So pay per use, and the scaling up and down is also handled in the backend. That is done by technologies such as Kubernetes, Task, Hadoop, and even HPC in the back. On the output side, so your algorithms will generate results. And there we think it's very important that the output is really dissemination ready, so that you don't have too much work anymore when a geotiff comes out to be distributing it further to your own users. We do that by generating cloud-optimized geotiffs that can, for instance, based on the URL, directly be rendered inside an application like QGIS. That's also what is shown in the animation here. We complement that with good metadata based on stack. And there we try to, of course, follow the FAIR principles. So findable, so with standardized stack metadata, accessible over HTTPS, you can share those links. Interoperable formats like cloud-optimized GeoTIFF and NetCDF. And of course, reusable, because the whole process graph that created your data is also in the metadata. Then if we go on, this is actually then a new feature that we have in mind to also federate the processing. So what OpenEO actually allows us to do is that you can have process graphs that do not run only in one data center, but we can actually split them up across multiple data centers. So part running on Kubernetes and part on HPC. So these are things that we are now looking at, and that also the OpenEO specification allows us to do. Sorry, needed a drink there. Then we're adding things like credit monitoring. That will give you insight in what you're actually using for a job. And a service marketplace where you can share the workflows that you created and also discover other ones. And that's actually it for my presentation. So now I'm handing over.
Yeah, many thanks, Jeroen, for that insight into the technical concepts. With this, we follow now on with Alexander Jakob, giving you a little bit first experiences and also the aims and goals within our use cases and the general roadmap of OpenEO. So, Alex, the floor is yours. We can't hear you yet.
Can you hear me now?
Now it's perfect. Thanks a lot.
Okay, great. And you can also see my slides?
Yes, I can confirm.
Okay, great. Thanks. Okay, yeah. Then I'm going over and talk a little bit about the use cases and specifically also what capabilities they bring into the platform. And because these use cases, they're mainly designed for extending what you can do with the platform. We've already seen it slightly from Christian, but I take you to the slide a little bit slower so that you can follow it. So the first capability, of course, is getting access to the data and also data that's actually usable for doing something with it. So analysis-ready data. And that was what we implemented in the first development iteration last year already. Finalized in the beginning of this year, giving access to mainly Sentinel-1, Sentinel-2, and Landsat collections, and also tools for providing analysis-ready data there. So that's the base of everything. The next one, very important, the ones that we're currently doing were on crop features and also on near real-time forest monitoring. In these cases, the main capabilities brought into the project are the systematic feature engineering and pixel level phenology on the crop features, and then on the forest side, it's the time series modeling, which is the key feature, and also the change detection, handling, and event alerting and things like this. So to have a dynamic interaction with the time series that's happening, and that can be used for many other things, of course, as well than just forest change detection. Now we shift gears and start the next round of iterations right after this Phiweek actually, where we go more into the machine learning parts, the sampling of the training data that is needed to run the machine learning. Then we have also very important add-on with linking to commercially external data to make it available on OpenEO platform together with our colleagues from Synergize now. Then in terms of the processing capabilities, this canopy cover use case will also add downscaling capabilities and regression modeling as features into the processing. And then we have a large round of use cases in the last iteration that will bring even more features like looking into the vessel detection, doing high volume SAR data processing over the Mediterranean Sea, then going to more applied use cases also with the crop conditions for insurance companies to generate the indices that they need to do things like yield anomaly monitoring and things like this, and can create insurance based on indices and stuff like this. Then we have the flood risk mapping, where again it's full archive frequency reductions that run on very large scale processing, and also how to bring your own workflows more efficiently into the OpenEO platform. And then also another challenging use case doing the pollution monitoring with Sentinel-5P on the global scale, looking into also new features like temporal resampling and so on. This is just a great overview of all the use cases. So to show it a little bit more in detail. So the first one, the analysis ready data, I mentioned it already. That's really to help the other use cases to have the data that they need to be carried out. the main feature here is that we extended the processes of OpenEO to include processes for generating analysis-ready data. So it's not only that we have pre-processed data, but we are also able to dynamically generate all kinds of analysis-ready data, and specifically also with custom parameterization, so that users can generate the data in a way that is most useful for a specific application. Additionally, while doing this, we also made sure to be compliant as much as possible with the CEOS Card4L specification, and have also provided the first implementation of the CEOS Card4L specification in stack compliant format. And Matthias Mohr from University of Münster has generated for all the Card4L defined ARD sets also the stack definitions that are as extensions available and usable for anyone. But of course, they are also provided when the OpenEO platform analysis-ready data gets generated. In terms of analysis-ready data, we have also implemented a lot of different tooling there to really see what can be done. So we have built on widely known tools like Snap to be able to use that. But we have also experimented with new tools to do more efficient analysis-ready data on the fly generation, implemented now in the Terrascope backend using on the Sentinel-1 side Orfeo, and on the Sentinel-2 side iCore and SMAC. For the more precise and refined analysis-ready data generation, we use the Force software from David Franz, formerly Humboldt University of Berlin. I think now he changed to Trier University. And then there's also the Sentinel Hub, which with the predefined batch processing workflows accessible. So we have a lot of different tools, and you can also compare how they work and run. I think we showed this already in a public demo earlier this year, so some of you might have already seen this. And that's really nice that you can really custom tailor this chain to the needs of your application. Then currently finalized is the crop feature engineering, and linked to this also a European crop map that we are about to generate now during the project. Here we really, again, target very large scale areas. So this is covering half the European continent or something like this, 1 million square kilometers covered here for detecting as automatic as possible different types of crop. So the use case here brings first the feature engineering that is required for this, and then together with the other use case, also the actual mapping of that. And yeah, there are a lot of new tooling in OpenEO available to make this as simple as possible. Then on the forest change detection, this was from our side very interesting also, as we had a lot of problems here in the region where URAC is located with this with some very big storm events, and we use these as test cases to validate the processing chain that we have set up here based on harmonic functions. But basically with the new tooling that we've brought in here, you can do any kind of pixel-based time series model fit now, and you can use model fitted then also to do predictions. You can then use this also to change detection, and based on change detection alarming system, and have a whole dynamic chain where you can recreate new models when you have discovered changes and so on. So really providing a lot of tools that can be applied for many different use cases later on. Now, as I mentioned already in the forest canopy fraction canopy cover, we are looking into introducing VHR data, specifically also coming from planet data sets, in order to have very high resolution and to use downscaling between Sentinel-2 and Planet Lab in order to do very nice canopy mapping. Again, here the features are usable in this specific use case, but also in others, so you can see where this is going. The main idea is always that all of these use cases bring a lot of more features into the platform, general processes that can be applied by anyone for any kind of application, and these use cases are just one way of using them, and we hope you as the users are then creative to use them for many other things as well. Important aspect coming in here is, for example, also uncertainty and tracing of this kind of information, which is also, of course, also very important in general in all the EO workflows. Then we have the dynamic large area land cover mapping carried out by Vito. I'm bringing a lot more different classes in here, and specifically the machine learning parts into the platform, so that these features are also available. And that's also one of the most requested features in general that we hear when people ask about OpenEO if they can machine learning. So it's very important that we start to tackle this domain now also. And then there are even the other use cases that I mentioned earlier. But I guess I also don't want to steal away too much of the time for the next speakers. So I will just quickly go over these here. So the maritime vessel detection in the Mediterranean, that will this phase, which is also interesting, and we will bring new project partners in that are not based in the core development team to really work on the use cases and give feedback also on the usability there. So this is Planetech Italia on the one hand side. Then University of Münster switches roles from just developing but also applying a use case here with the Sentinel 5B. Then we have the Österreichische Hagelversicherung, as I mentioned already earlier, to really work with the index-based insurance models and see if they can work out well. So where do we stand on the roadmap? Christian has already mentioned it. We are now somewhere here in the center, but as you can see here also on the right hand side, the project will be extended even further, and there will be some more things also to tackle that we want to bring into the platform. Some parts have to do with improved visualization of the online maps and results to make them browsable accessible more easily. You saw already some of this in Jeroen's slide with the direct links of the cogs, but this can certainly be done even better. Another thing is supporting the interferometric SAR data better. We have already some ideas about this, and then also bringing even more machine learning methodology in there. So there are quite a lot of different topics that we are already targeting then for next year and further on, in order to really bring as much as possible useful functionality in here. Yeah, with this, I'm already in the end of my presentation, and now Daniel will give you an overview of how to actually get started with using all of these nice things that we have presented so far.
Yeah, many thanks, Alex. Just jumping in and just mentioning, now we are at the end of the presentations block. So now the technical demonstrations start. First one will be Daniel giving us insights how to actually start OpenEO and how to get into it. Yeah, so Daniel, the floor is yours, and you can already start to share the screen.
You can see and hear me?
Perfectly.
Yes.
Okay. Okay, so yeah, thank you, Christian, for this nice introduction. As already said, I will give a bit more hands-on and a bit more practical information to you now in the next 15 minutes. First, I will inform you where you can find some information where you can get started. Then I will explain some general basics. Then I will show you how you can actually authenticate to use and interact with the OpenEO platform. And then in the end, I will show you a few basic things in a notebook, where I will then show how you can use the account to connect to OpenEO platform and how to get your first data loaded. So where to get started, we set up a homepage that you can find at openeo.cloud, and this is the first point that you should access when you're interested. It gives you a general overview about the project, but also already some overview about the data collections we have available and the processing capabilities. We have a news section where we post news about the development progress. We have some information for the early adopters available there. And you can also find contact information in case you want to contact us. Then from there, you can get to the more technical homepage at docs.openeo.cloud, where you find everything to really get you started with the platform. You find again an overview about the data collection. You find some detailed information on how you can get started. You find a nice overview about the use cases that Alex also already presented to you before, and some more information. When you then go to the Get Started, you will see that there are several options how to use the platform. On the one hand, we offer 3 different client libraries, one in JavaScript, one in Python, and one in R. But it's also possible to directly interact with the platform in a development environment. And for this, we have some hosted Jupyter notebooks or the web editor that will also still be shown to you later. For the Python library, for example, you can get then a whole documentation page, and also at the bottom you find then the technical documentation where you will find all the details about the library, how to set it up, how to use it, how to report anything that you find. Now coming to the authentication, here we collaborate with EGI, and you can for this use an existing academia or social platform account, and this has several advantages for you because we actually don't store or handle your password, so it's a very safe option. Then we only contain the minimal information about you as a user. And lastly, something that I find really especially useful, there's no need for you to set up and remember yet another username and password, because you can use an already existing account that you either have from your academic institution or some social platform account that already exists. And now I want to guide you through this process, how you set this up. The authentication setup is split into 2 different parts. The first one is that you register your existing account with the EGI. You join the EGI user community. And the second part is that you join the OpenEO platform virtual organization. And here it's really important to do the first step first and only then the second step, because otherwise you will receive an error message. So how does the registration with EGI work? You simply go to this URL that's shown here, and then you will get presented with this login screen where you then can choose your academic account or one of these social accounts displayed here. Then you use that to check in, and you will get asked to sign up for the EGI user community. And then you wait a couple of seconds and you get presented with a really short form where you maybe still have to fill your organization, but it might be already pre-filled for you if you use your academia account. You have to review the use policy and agree, and then click submit. Then you can wait a couple of seconds. And with this, the registration so far is completed, and the only thing at this step left to do is confirm it via email. So you go to your email where you get a welcoming message with a link. When you click on the link, you will get the screen shown on the left side where you just click accept, and then wait again a couple of seconds. And with this, you are successfully registered within the EGI user community. And this whole process shouldn't take you more than a few minutes. And then the thing left to do to really use OpenEO platform is to register in our OpenEO platform virtual organization. And I will also quickly show you how this is done. You go to this link, and you see here that on the top right, Phiweek test account that I am already logged in. You might get asked to log in with the account that you used. Then you click on begin. And then as we can see here, you wait a couple of seconds, and then you will be presented with a form for the OpenEO platform community virtual organization, where you are asked to fill a comment to explain to us why you want to use the platform or what you want to use it, so we can review this in the early adopters program. Then you have again at the bottom a use policy that you open and agree to, and then at the bottom you click submit. And with this, you are actually already through the whole process. It says then petition confirmed. And now the only thing for you is to wait for us to review your registration and to grant you access to the platform. All this information is also accessible on our documentation homepage, where you can find the single steps that I explained to you now, again in a bit more detail. And now coming to the second part of my presentation, where I will show you some basics in a notebook, how to connect to the platform, how to inspect collections and processes that we have available on the platform, then how the authentication actually works when you use one of the libraries, or when you're in a notebook, then how to load data and how to run a process. And this is the basis for the later use case demonstrations. So to give you a good general understanding of how these basic things work, so that you can easily follow the more advanced things we want to show you later. Okay. So the first thing you do is you import the OpenEO library, and then with the OpenEO.
I think you need to change your sharing now. We see still the presentation.
Okay, thanks. I will just stop it quickly and start it again. Now you should see it.
No, it's fine, yes.
Okay. So here's the notebook, where you can see that first you have to import the OpenEO library, and then you can already directly connect via OpenEO to openeo.cloud. And then the first thing you can do, without having to be registered or anything, you can list the collections that we have available and print them, and then you get presented with a very long list with a lot of metadata and information. So if we check now only one of these, it will be a bit easier. You see there's a description, there is a extent, and also an ID that can then later be used to access this collection. Also with the describe _collection, you are able to get a bit nicer overview of this collection, where all the metadata that we provide is shown to you in a more easy to digest way. As said, all this information that's shown here is also on our docs.openeo.cloud under data collections, where you also have a nice search functionality that lets you search through all available collections. Similar process you can do with the processes that we offer. And when you request it, you will get a long list of all the processes that the OpenEO platform has implemented and that you can do with the data. And when we look at just one again, you will see there's some description, there's some examples, And as this is again not so easy to digest, you find these processes nicely listed on our documentation page, where you can search them and also then get a nicely rendered overview about each process and how to use it. Then next I will show you how to actually authenticate so that you can do a bit more with the platform. And for this we just remove any token I might still have saved, and then you can use this authenticate_OIDC to connect to EGI, which then will be used for the authentication. And if we do this, we will get the message to authenticate, visit this page and enter this user code. So we will copy it. And then we will see on the top right, Phiweek test, that I'm already logged in with this account. If I wouldn't be, you would get to this start screen where you would enter your credentials from your academia or social account. And now when I pass the code here and click submit, I get some information what I'm actually submitting to. And now after authorize, it tells me the device has been approved. You can close this window and return to your approved device. And now when I return to the back to the notebook, it says authorized successfully, and I'm with this account connected to the OpenEO platform. We can also check this with the describe_account and see which role I have. This is the early adopters that's connected to my account. Lastly, I just wanted to show you that now that we are authenticated, we can load actual data. This is done with the process load_collection, where we specify with the ID which collection to load. Then we can specify a spatial extent for which we want to load the data, temporal extent, and also the bands. And now I have the data loaded in a data cube. And small reminder, the data cube concept we use in Openur platform is just a multi-dimensional array with one or more spatial or temporal dimensions. And now that I have the data in my data cube, I can apply further processing on this data. For example, I can use this min_time process, which reduces my data in the time dimension. And with this, I'm finished with this basic introduction. Now that you have loaded the data, you can do much more advanced and interesting things. You can apply a lot more processes. You can analyze your data and visualize it. You can save and download the data. But this will still be shown in the next examples to you. So I will stop sharing and hand over back to Christian.
We cannot hear you.
Sorry, I forgot to unmute. Yeah, classical issue. No, many thanks, Daniel, for your contribution and showing us and giving us insight on how to log in and how to get access towards OpenEO. In the program that we have set up, we have now a break of 10 minutes. So we are 5 minutes in advance, but I think that's actually quite good because then we have a little bit more time for the practical demonstrations afterwards. So therefore, I would just invite you to do 10 minutes break, and we will continue 10 minutes past 3 o'clock directly here, and again following on with the presentation of some technical possibilities and use cases. Thank you for being around, and we are back in 10 minutes.
since I'm not physically there, if anyone from the audience just want to chat or hang out here, you can also just talk.
Hi, Alex. It's Marcus. Can you hear me?
Yes, I can. Hi, Marcus.
Hi. So I put a question on the chat about the Sentinel-1 processing, about the difference between Ortheo and Snap. So could you open a bit on the benefits of using Ortheo for that? Thanks.
I think that was in the way of how Vito has implemented the processing chain in their tooling. It was easier to really do pre-processing on pixel level also, and make it very arbitrary. So just work on very small subsets of the data, and in this way do a very quick on-the-fly ARD generation. I think that was the main background there. But yeah, I think we can discuss this also in more detail than in the discussion session, so that also the developers can give a concrete, more detailed answer to this. But the main background is this, that this was a very neat way of efficiently inject this pre-processing in the process chain without using many resources, and get a very quick turnaround of ARD data, especially for prototyping in smaller areas.
Okay, thanks.
So just to announce that we are coming step by step back, so give us a few seconds that everybody is settled again. Then we continue with the technical part and the technical presentations. Yeah, I think I can already announce. So the first presentation will have a focus on ARD data, and the second then on forest detection. It will be presented in a demonstration. There's Matthias in front. Oh, sorry. And then I mixed up the agenda. I maybe then skipped just the line. So before then we go to the use cases, we have Matthias Mohr presenting us further technical insights. So I hope, Matthias, you are around and I can then directly hand over to you.
Yes, I'm here.
Perfect.
Good afternoon, everyone.
Yeah, and sorry that we mixed up the agenda.
I will start sharing the screen.
Yes, I will just wait that we can see it. So content is coming. Yes, we can see now your screen and we can also hear you. So the floor is yours. Thanks a lot.
Great. All right. So if you want to get started with Openeo platform, of course, if you're programmer, you can hop directly into Python or R. But maybe sometimes it's nice to explore the platform first, or you're not so much into programming, then there are other ways to use it. And I'm starting here with the technical documentation page. And usually you start with data that you want to process. And here's the list of data sets that we have. And today I want to crunch some numbers. So I'll start with some pre-computed NDVI data set here and see that there are 4 data sets, and today I'm using the Terrascope Sentinel-2 NDVI data set here. And see all the metadata that is around and can see what is available. And then I can start a tool that is called the OpenEO Platform Editor, which allows us to get a preview of the data that is available. So I'm opening that up, and it directly loads up the data in the map here. And I can scroll around and see what data is available on which dates and get some previews. And also, if I don't want to use this data set, I can just clear it and see all the other data sets and, let's say, visualize another one. And scroll through and see what's going on. This is not only possible for the collections, but also for the processes, for example, because every data collection you need to process with some predefined processes here. We have quite a number of them, and you can do variety of use cases with them. Usually you start and want to drag and drop some data in here. So I'm looking for my NDVI collection again, and just can drag and drop it into this view. So this is a very simple view for beginners. If you're into Python or R, you would probably want to start with the R or Python client that you can see later. But just for some experiments or for beginners, this could be a good option to start with. So this is what Daniel has shown before in the load collection process. Basically, we are loading the Terrascope NDVI collection here into a data cube. But before I forget, of course, I'm just in mode where you can just explore the backend. So before I start and really send something to process to the backend, I need to log in. And this is going through the EGI check-in again, as shown before. So I'll log in now, and it asks for my GitHub credentials, which I've inserted before. In my case, at least, it's GitHub. And now I can see I'm logged in. Nice. And now it allows me to do even more. You see there is a batch job panel appeared here. And now I want to really process some data here. So can have a look quickly. Spatial extent we've seen before. And we have data from 2015 until now. And we have 2 spectral bands here available. So what I'm doing now is that I'll go ahead and reduce the time and make the mean of the year. And so as such, I can just like drag and drop processes here. Say that I want to compute the mean over the temporal dimension, save it, but still I need to also select where I want to compute. And today I'll go to, let's say, somewhere in Amsterdam and compute data from 2020. 2020 until the end of 2020. And I would like to compute on the NDVI 10 meters band. Save that. Now that's my input data. Now I'm reducing the temporal dimension, computing a mean, and just for simple processing and visualization, I'm just saving that now into a PNG file. And now I can decide whether I want to run that as a batch job or as a synchronous job. The difference is that the batch job is basically for larger scale processing, and it is then just queued into the backend system and run, and you don't need to wait for it. And at some point you will then get details about your jobs. Or I can run it now, which is directly sending the backend request and then returns with the results. And that's what I'm doing now. So, and while we're waiting for that, I want to show the batch jobs that were shown here, but for some reason, my connection timed out. So I won't be able to do that right now. Let's open the other one that I had opened before. So if the connection doesn't time out, then you would see like a list of batch jobs here that you may have started before. You can track them over time. They update automatically. So if you have like queued something in the background, then it will queue, and then at some point it will tell you that it's finished. While that is running, you could, for example, also open a log view where you can then see in near real time what is going on and check whether everything that is working correctly. You can also, for example, load up existing processes and edit them. And yeah, I guess I need to log in again just for whatever reason. EGI is not doing what it should do. Let's try again. Yes, that's the issue with live demos. When there's something not working, then you're screwed. I'm not sure what's going on in the background right now. Yeah, well. I guess that won't work. I'm not sure what's going on. Let's close these. And try it in another browser. Well, I had this issue before. I don't know. It seems either my connection is not correctly working right now. Something other. No, I guess I need to pass on to the next person and hope he has better luck with the infrastructure.
I think there's one recommendation from Michele coming in the chat. If you could show the graph to code conversion, and maybe we can then later come back to you.
Yes, I can do that. You can drag and drop, for example, some processes here again. I had hoped to show that on some other stuff, but anyway, let's quickly drag and drop something again in here. Really care. So one feature that you have is that if you want to compute on bands, for example, band mathematics, it's easy to just like type in formulas here. That is very easy. So if you want to have the first band minus, for example, an NDVI, and want to subtract the second band, and then it automatically generates the graphs for you. You can save that. And if you have something prepared here and you want to go over and fine tune it, for example, in Python, R, or JavaScript, you can export that to code. And it will directly give you, for example, the JavaScript code with the formula in here. And you can copy paste that into whatever environment you would like to work in. That's working for JavaScript, for Python, and for R, and start from there. Yeah, so that is something that all works here very well. So you have a nice visual overview over all the things. And usually you should also be able to manage your batch jobs, see what's going on, see the logs or edit jobs and store them again, modify them, draft new processes and visualize the results here. But yeah, sometimes it works, and today I have no luck. So next person, please.
So yes, Matthias, yeah, maybe you can try it in between, and maybe we have a slot afterwards where you can follow on. I would suggest that we go ahead with Michele now presenting us actually two use cases, one on ARD data generation and the second one on near real-time forest mapping. So Michele, the floor is yours.
Thanks, Christian. Let me try to share the screen from another notebook. Just a second. Share. One. So, did it work? No. Firefox. Share. Okay. So let's wait for the content to appear. Okay. So, hi everyone, I'm Michele Klaus, I'm from Europe Research, and I'm working together with my colleagues Alexander Jakob and Peter Zellner, who will also present the R client later. And today I'm gonna first present the use case of ARD generation, so analysis ready data, and the work that we've done during the past months. And yeah, I wanted to start showing you the GitHub repo where we collected the notebooks that we'll show today. which is here on under OpenEO platform sample notebooks. On the OpenEO platform main repo, you would also find other repos with different notebooks. So in case you're not finding the function that you're looking for in this one, either look for it or just ask us and we could provide some hints where to find the correct one. I've included in the README file some instruction on how to create the correct Python environment to run the notebooks. And also I've added a clear notice where you must be an early adopter to run the code provider, because otherwise you won't be able to actually run the code, and it will give you an error stating that you are not an early adopter. To actually run the notebooks, we have two possibilities. Either you run on our OpenEO platform Jupyter Hub environment, which could be accessed via this link, or you could even install the Python module locally and just run them as you would like on your local machine. So now let's go to the ARD notebooks. I split them into two notebooks. The first one showing the optical ARD generation pipeline, and the second one showing the radar ARD. So let's start with the optical part, and everything starts importing the OpenEO library and some utils function that are needed to visualize some widgets that we'll see later. First of all, I want to remark that you always have to make sure to have the latest version of the OpenEO Python module, which must be greater or equal than 0.9. Otherwise, there could be some features that are present here in the notebook that are not available in the previous version. So always make sure to have the latest version installed. As shown before by Daniel, first step is actually connected to the OpenEO platform backend, and I'm already connected, so it doesn't require me to reinsert the credentials, which is really handy because it's super fast. And with this widget, we could start interacting with the map. We could select an area of interest, and yeah, basically it is just useful to get the coordinates of the area that we would like to use for the further interaction with the data, which, for example, Matthias showed in the web editor, and here in Python can be achieved using the IPy leaflet widget. Maybe Daniel previously forgot that even here in using the Python client and the Jupyter notebook, we can have a nice rendering of all the collections available. You can just use list collection and you can start looking for what you would like to use. For example, we'll use the pre-computed ARD Sentinel-2 collection, so it's called BOA Sentinel-2. And if you use the, let me scroll down all the collection. If you use the describe collection method, we'll get the whole metadata of the single collection. This is pre-processed with force, and we can get the spatial extent, temporal extent, and so on. And also, yeah, also the band names, descriptions, wavelengths, and so on. And we also have all the documents describing how the collection has been processed, because that's a key feature we want to stress, that we are transparent not only in the code, so we are open source, but we also are open source in how we process the data and how we want to let the user reproduce the results even in the pre-processing step. So after selecting an area, we can proceed, as Daniel showed, with the collection name, with the spatial extent, temporal extent bands. Now I've selected the RGB bands just to show a simple example. After that, we save the result as a netcdf with this save result process, which is basically the same that you have seen in the web editor graphically, but here is Python code. And as shown in other examples, we can either download directly the data if it's a really small extent. Otherwise, we have to create a batch job and let it run. So after a while, after we create the batch job, so the job will have assigned an ID. And with this ID, we can retrieve the status of this job. And once this job will be marked as finished, so it will go through queued, so in the queue, then running, and then it will be finally finished. Then we'll be able to actually see the result as a file, but also all the metadata behind the result. Because again, we want to stress that you can have all the details about the processing. So here you can even see graphically the process graph that we created. You can see other details about the process that we've run, and you can download via a link the result. You can either use then the browser to download the data and continue your processing somewhere else, or you can also download the data directly here in Python. Additionally, I want to say that we work together with CEOs for being CADFile compliant with our processing, and for both the optical and the radar part. So after that, we have downloaded our netcdf file. We can open it using X-ray, for example. We'll get the temporal, spatial extent, the bands, the projection, and finally, we can just have a look at the result as an RGB composite. An additional feature that previously has been mentioned is the on-demand processing. So now we just used a pre-computed collection. You are also able to basically decide which processing engine to use to pass from L1C to L2A for Sentinel-2. And for example, here there's an example calling the iCore pipeline or the SMAC. And we can use both of them. We can download the result again, and we can have a look at the result over Bolzano, where your research is placed somewhere here. And you could even inspect the differences between those two methods. So it can be useful for checking if something goes wrong with one processing. You can even try another one, or you can just evaluate if there are actual differences. Okay, this is it for the optical part. Now I'll switch to the radar part. And again, the notebook starts with the previous recommendation about the OpenEO module version. And yet again, the selection of the area of interest. Here you can even turn on or off the satellite background. And now we can try to produce on-demand SAR backscatter, which is performed using this ARD normalized radar backscatter process, which calls on-demand processing. Additionally to the optical part, for Sentinel-1, we can even filter the orbit direction, which can be handy for particular use cases. Then we can even pipe the conversion between linear to decibel scale. And at the end, similarly, we can download the result. I have to mention that if you download the result directly using a synchronous call, you'll just get the single file with the file that you, the output file of your processing pipeline. Instead, if you create a batch job, you'll also get all the metadata behind. So if you want to create something which is reproducible, please use the batch job, and then download also the JSON metadata file. Additionally, in order to be CAD4L compliant, the ARD generation allows you to not only download the result, but also the source files. And it is possible to download all the source files that have been used to generate the results, but just keep in mind that those source files are just the full tiles that have been used and that are really big in size. So it could take a lot of time to download the full packet of files. So once we have downloaded the data, we can again inspect it. We can do whatever we want, just visualize it or do further analysis. Additionally, the SAR backscatter process, which is different from the previous one because the previous one is more focused on generating ARD CAD4L compliant data. The SAR backscatter process allows you to choose among different coefficients, so beta, sigma, and gamma, and yeah, they can be either terrain corrected or not. Maybe something that I haven't mentioned before, the process allows for further parameters, and for example, you can choose the DM, which is used for the terrain correction step, and it could be either Copernicus, or there's also Mapfen, which is based on SRTM. And you would find all the details about the different parameters in the process description, which can be either on the website or described here directly in the notebook. Okay. With this, I've finished the part of the use case 1, so with ARD data, and I'll switch to use case 6, forest change detection, which I have here. Let me go quickly to the top. Okay, so here I am again. We'll start another example. This is a bit more complicated because we're not just generating some data we'll use further for other processes, but we are actually using this data to for a specific use case. The processes used for this use case are currently on development. They are available, but there are still some issues we have to solve. So currently I'm not connecting to the OpenEO platform backend, but to the URAC one. But once it will be ready, it will be published on GitHub, and the functionality will remain the same. Someone missed the instruction to register for OpenEO platform. So if you go on GitHub here on OpenEO platform sample notebooks, you'll find the links for registering. So if you open the openeo.cloud also website, and if you go to early adopters, you'll find all the necessary instructions here. I see that Matthias also posted the link. Okay, let's go on. So I was saying that, yeah, now we are talking about this forest change detection use case. Just want to show where we are actually. We are in North Italy. I mean, not right now, because now we are in Frascati at the ISWIN headquarters, but I want to focus on a particular area that has been affected by this storm a couple of years ago. And you may see that on OpenStreetMap layer, this brownish area has been already somehow marked as no more forest, because previously it was all green. And yeah, basically this is the damage that the storm did. So basically we want to focus on this area and see if we are able to detect the changes that happened after the storm. So again, we start with loading the data. selecting particular bands, applying the cloud masking, and so on. The particular thing here is that now we have a time series of data, and to each pixel we want to apply function fitting, because we already know that forest has a seasonal behavior, and therefore we would like to apply to fit this seasonal function to the data. Because if the data is stable enough, here for example we use 2 years of reference, we'll get a nice and smooth fitting to the data. So this particular part is performed here, where we define the fitting function, which is the combination of sinus and cosinus. And then we call the actual fitting using the fit curve process. We can even give the initial parameters guesses. We set the dimension because we want to fit the curve over the temporal dimension, and then the function that we just defined. After that, we can proceed creating the process graph and saving the result. Later, once we compute all the coefficients that we need for fitting the function, we can reuse that. We can reuse that using the load result, which is a really nice process that allows us to reuse data that we previously generated, always using OpenEO. And with the curve predict curve process, we actually fitting these coefficients. We are fitting the time steps that we're interested in, and then we'll get the predictive values that are following this model. In order to, let's say, better understand this process, I've shown here a little example. So for this particular point that I've selected, this is the result in time series. And in red, you'll see the predictive values following the model, which has been fitted until the days before the storm, so until September 2018. And you may see that after that period, the data deviates a lot from the model, and that's what we actually want to use to find the changes in time. You may also see the same thing here. Another way to understand how this fitting and prediction model works is to actually do it not in time, but in the spatial domain. So here I already created an example. Let's see if I can. Okay. So for example, let's start looking at the satellite image. If it works, yes. This is just a satellite image, and we'll now overlay an RGB image that has been created for July 2019 with the model. Here it is. So basically you see that there's not so much difference. But instead, if we want to see the actual data from July 2019 after the storm, this is what we would see. And basically this model fitting and predicting could be also used for gap filling, as you have seen. Okay, so basically this is this concept behind this change detection use case. And at the end, after applying some thresholding over the data, we would get a map showing us the area that is being affected by the storm, and that changed from forest to something else, actually. This could be also used for other types of data, and yeah, not only for forest, but in this case, we were focused on forestry detection. Okay, I think I'm done here. Thanks a lot for your attention, and I'll give the word back to Christian.
Many thanks, Michael. And I actually directly hand over towards Jeroen, focusing on crop maps.
Thank you. So I prepared some slides for this particular use case because it's also a rather larger one, in fact. We focused on crop classification. It's a very well-known problem, of course, in the agriculture domain or remote sensing in agriculture. And we wanted to classify 5 major crop types in a region covering 5 countries. So that's what we've been doing for the last months. And this is immediately already the result. So you see that we processed over 100. Oops, you're not seeing anything. How do I share here? Back. Wait. Good. That should be, oh no, wrong presentation. Wait. I'll just share my screen, that's easier. This one. Good. Sorry for that. Oh, one back. Good. Also now you should see the result. So you see these 5 country areas. The colors on the gray tiles are basically the crops that we classified, and you clearly see the regional differences. In this use case, actually, we didn't focus yet on the scientific validation. We just wanted to get the workflow running. We did reach some accuracy level, but of course not yet enough for what we would really want to release to the public or anything. So it's really more of a technology demonstration still right now. And then over the next months, we want to actually evolve it into something that can be offered as a service and as a product that is available, in fact. If we zoom in a little bit, you also see nicely that we detected some, quite a few fields. The cropland mask was used to focus only on potential crop pixels. So that's why we were able to filter out everything else in an easy manner, using OpenEO, of course, because we can do masking in there. Also, what is then very important for a platform like OpenEO, which promises scalability, is the production statistics. So we had this 110 plus MGRS tiles of 100 by 100 kilometers, and each input was Sentinel-2 data and about 20 months. We focused on one growing season, but because you need to interpolate the time series a little bit to fill gaps in the clouds, especially in winter months, we extended it to 20 months. And we classified using a random forest in a Python user-defined function, which is an OpenEO feature that allows us to run Python code on the OpenEO platform. And the random forest was integrated in that way. The duration, typically for a tile, is actually shown here, was somewhere between 30 and 60 minutes per tile. And then if we looked at the cost, so based on what CPU and memory was used, we ended up in this particular implementation at around €3 per tile. That's an indication. It's not yet, that's not the end point. We may actually want to improve that further. But that gives you an idea of where we are today. If you look at the workflow, it was quite a bit. So we really are moving in the direction of something that could really be a production workflow, with cloud masking first, then 10 daily composites that we created. Those composites needed gap filling, so we need to do linear interpolation over time. And then to do the random forest, we need input features. And those features are based on the bands and on vegetation indices. What we did then was quantiles, mean, and standard deviation. Those features were then extracted for samples where we knew which crop was growing there, and that gave us a data set to train the random forest model. Masking was done with a cropland mask, and then this trained model could be used in large-scale production using this user-defined function to generate all these styles. And the thing is that all of that actually happens in one workflow. So the whole end production really starts from the Sentinel-2 data, and then this one processing graph that computes the result in a single job. Then I wanted to zoom in a bit on some of the steps in this workflow. One is compositing. So you see that it's rather easy. You do aggregate temporal period for decades, and you take the mean in this case. And then the second thing already is array interpolate to get rid of gaps. And then if you request a time series from there, you see that it's really with equally spaced time steps. Another thing that we actually did before this implementation was a rule-based stratification. That's more based on expert knowledge, where you compare the NVI or other bands at different time steps, and then you can create like expert rules to try and classify a given crop. And that's also something that's possible in OpenEO. So you can set up a data cube that contains the different months actually as bands, also together with the different bands. And then you can just write the rules in a very intuitive and readable manner. So we were also quite happy with the result we got there. And then we had to, we looked at the profiles. So you see these box plots. That is what allowed us to basically tune these rules. And this is then finally the output. That was also run for a 5-country area. And there the cost was more like €1 per tile, but it was harder to tune, so the accuracy was a bit lower. Finally, some work planned in this use case. I mentioned it already. So we actually want to integrate Sentinel-1 data as well to help improve the accuracy by having an additional data source. Similarly for Meteo data, then doing some performance improvements to really further reduce the cost per tile, and finally then scientific validation and a full production. And then we hope that this can be offered really as a service to a broader audience. That's it for the crop classification. So back to Christian.
Yeah, again, just being back shortly to announce Peter, also showing us now further aspects around OpenEO, especially the R client, and the possibility to use R in the context of OpenEO platform. Thanks, Christian.
I will also take one short second to share my screen. And I hope this is visible now. Yes, seems like it. Welcome again also from my side. And now we have seen all that is possible with OpenEO already, especially things that have been implemented with the Python client. So elaborated use cases have been produced. now we're going back a little bit to the basics and introducing the R client, which has started a little bit delayed on time. We have reached out to ESA to get an additional project running so that we can onboard also the R user community again into OpenEO platform. Since we've also seen that there is some interest from the R user community, we've gotten letters of support. We've seen that the issues on GitHub continually were logged. And yeah, it's also a different crowd of researchers that we're addressing here, maybe some more statistically working people, maybe some modelers, some climate researchers. And we're just trying to enhance the diversity and opening up the platform to as many people as possible. So I will show you now the look and feel of the R client, and we really aim to integrate this in the R ecosystem, making use of RStudio wherever possible, the viewer components, using the geospatial tools that are available, using the tidyverse as much as possible, and just trying to give our users an adaptation that is as easy as possible. So many of the things you will probably have seen already throughout today, but let me show you how this looks in the R environment. So here you can see RStudio. Here's also some information that you can go through at home. There's the Getting Started guide available, also on OpenEO.org that you've seen. There's the Getting Started guide from OpenEO, from the initial project, and also the repo on GitHub, where we invite you to log issues when you try it out and let us know what you want to do with the R client so that we can enhance it also in a user-centric direction. The first thing is how to install the OpenEO R client. I've already installed it. Currently, you install it via the remotes package, but it will be forwarded to CRUN soon, or we will at least submit it to CRUN. So then this step will also be a little bit easier again. Here I also suggest you to use the newest package version. Currently it's 1.01, so that you have the newest features available. Here we're loading some libraries from the R environment that you probably all know that are very helpful in geospatial processing. And then the next step is already to connect to the host. So here you see that we have connected, and when you are actually working with the R client in RStudio, you will see that here you have now this pane populated, the connections pane, and you have all the available collections already available in an interactive way. And if you open it up, you also get the metadata, and this is always the same metadata that you've also seen before in the Python client, in the JavaScript client, and also in the web editor, and also on the home page. So this is harvested and presented here in a convenient way. So the discovery of the backend is already possible while you're connected. Any processing you want to start, for this you have to log in. This is the next step that I will show you now. Currently for the R client, we still need a client ID and a client secret. This is due to the way that it was implemented before, but we are working on it to also implement the device flow so that you don't need the client secret and client ID anymore. If you want to use it currently, the R client, please reach out through the forum. I've linked it up here, or through the OpenEO support, OpenEO platform support, that we can provide you with this client ID and client secret. But then you will see it is the same mechanism. You're forwarded to the EGI check-in page. Then you click on authorize, and a page is opened that reverts you back to RStudio. And then you see after completing this that the login was successful and you can continue. So here again, you can programmatically retrieve the names of the collections that we have seen. I think another interesting thing is the collection viewer that we've also seen implemented in the Jupyter notebooks. Here you will have it in your viewer pane, and you see that you have the metadata for the different collections nicely rendered in an HTML page directly shown in here our studio environment. So this is a little bit, maybe if you start using collections, should I continue? If you start using collections to get a first overview, then if you kind of know what you're doing, you can also retrieve this information programmatically. Here, for example, I'm extracting the extent of a collection, and here viewing the bounding box. So, but you can also extract the bands and use them further in lists, etc., loop through them, extract the names of collections, loop through them. So this is also all possible. And here you can also see the nice integration with MapView, for example, that you get these interactive maps also in our studio directly. For the processes, it's generally the same. You can get the names of the processes. You get also the metadata for the processes. For example, for atmospheric correction, you see here what the different parameters are and how to use them. If you use describe process directly, then you can see that this is also retrievable in a programmatic kind of way. So now what I would like to show you is a really easy example of building a process graph. Here we will load Sentinel-2 data, do an atmospheric correction on the fly, and then calculate the NDVI, aggregate it temporally, and show the results. So first you can also pick an area of interest. Interactively. Let's also go to Frascati, where we currently are. Maybe look for a vegetated piece here, something that seems suitable. You can also use the satellite images below to pick a field, for example, and let's just do this here. And so this is like how you can interactively set your bounding box, then you convert it into a format that is readable by OpenEO. You define the collection. Here we're using Sentinel-2, the year 2018, the bands that are necessary for an atmospheric collection. So these were the definitions up front. Now we're loading the processes into a variable that is called, I have called it P for now. And if you want to see which processes are available, you can always do names P. I'm doing this down in the terminal, in the console at the moment. And you can also use auto-completion, which is really nice. If you don't know which processes are available, you can here scroll through all the processes, which really helps you, especially when starting. And if you continue, you can also see here that you get the auto-completion also for the parameters to use. So I think that is very helpful, as said, especially when starting. So here we're doing a load collection that we've seen before, using the parameters that we have defined, and also then atmospherically correcting the data here. And here you can see also a nice feature is the pipe operator, which is frequently used in R. So you can pipe together your process graph with only writing it to one variable. So you can chain this as long as you want to. Now I've only chained the atmospheric correction process, but we could also chain the NDVI calculation, the reduced dimension, so in the same manner. Then here I define some intervals for getting monthly values. You can apply labels to it and then use the aggregate temporal function. You save the result in netcdf format. And here you can also check what you have done. This is also the internal representation in, let's say, OpenEO syntax is quite long. Okay, then you can compute the result. This might take a minute now, I'll just run it anyway. Oh, maybe I've been logged out in the meantime. But here I've loaded the results, and you can see that here the time labels are conserved, so you can continue using them. And here's a visualization of the different layers using the map view package, which is really nice for interactive visualization. Then you can also compare what you've done. For example, here we're looking at the NDVI in March. You see it's still a very different situation that you will find. Then in May, you get more yellow values, which in this case mean a higher NDVI up to July, where mostly all of the vegetation has reached its peak, and then you peak. And then you see in November, there are lower values prevailing. Yeah, and this you can also, as seen before in the Python client as well, you can also combine this with the base maps so that you really see the different fields and the different crop types. Okay, here you can see plotting the whole time series, where you can also see the evolution again of the different months. Then if you want to draw a pixel time series, you can use basic R syntax that is probably all known to you. You can define a pixel and also throw this into the process graph and require it. And then using ggplot, for example, plot the values here, and you can see that you get an interactive graph that gives you the values and the time steps, which is, I think, a nice way to check data. If you have collections now available on OpenEO platform that have the NDVI, that have LAI values, and some processing that you do in-house, you can easily compare, for example, different values, different atmospheric correction methods, etc. And that was mostly it from the R client side. Maybe a short note on the UDFs, that we are also working on getting our UDFs back running, so that you can use arbitrary R code, for example, as Jeroen has just showed with the Python client, the random forest classification, some machine learning. So we're focusing on getting that back alive and making easy data access available for local prototyping, and then sending, for example, a trained model through the UDF to the backend and scaling out on this.
So Peter, many thanks for giving us insight into R, and also a quick comment towards the UDFs. The next topic that we have in our agenda is looking at user engagements, and again mentioning how you can contribute, how you can support, how you can get an early adapter. So that was already mentioned in the first talk by Patrick Griffins in the morning, and now Jeroen will tell you more about that and provide you further insights.
Thanks, Christian. Let me set up my presentation again. Okay, good. So this is actually a very interesting part for some of the people in the chat that were already wondering how to register, and then maybe also expecting to immediately get access to the platform. Because the release today is mostly for early adopters. And this is a way for us to get feedback on the platform for a limited set of users, mostly because ISA has been so kind to actually sponsor this set of users so that they can get free access to the platform, that you don't have to pay it for yourself. And that way we can get good feedback on potential improvements. So you already saw the registration procedure earlier by Daniel. And then at some point you need to enter a I think it's called a justification in the form, but that's where we would like to hear from you, like how you intend to use the OpenEO platform. And based on that, we will be able to select a first group of users, probably in a couple of smaller groups at a time that we will allow. So hopefully next week already we can have the first group and then so on, depending a bit on the response. Selection will be based on your planned investigation that you provide yourself. Of course, also affiliation, where you're coming from, and basically with the idea to have a broad and diverse users group. Of course, it will also depend on the demand, so we have a number of accounts available, and depending on how many of you are requesting one, we will be able to give more or less people access. During your investigation of the platform, we would like you to provide active feedback on the forum, which is available through the website, so that, of course, that's the whole intention, that we can learn from that and further improve. And then actually, after the 3 months that you've gotten for free, there's also the chance to even extend the sponsored license. So if you have very nice results, if you have given very good feedback, then we will consider for those users to even further extend your account. So again, a limited set. Some users will probably then, not immediately have a project where they want to use the platform, but others might want to continue their work, and that gives them the opportunity. Then finally, at Living Planet 2022, we will organize a user consultation event, and that also gives those early adopter users the chance to present and participate, maybe the work they've done, or just feedback, and so on. So that's the early adopter program. Basically, it will take about 6 months with the Living Planet Symposium as an endpoint. So to be even a bit more clear, so it's all about giving feedback and asking good questions, exploring the platform, and very importantly, without really having too hard deadlines. So if you have a project and you need to process all the data tomorrow, or you're finishing your PhD next month and you need to get something done, or want an operational service, then it's maybe too early for using the platform, right? So it's really early adopters giving us feedback, but not yet with very hard deadlines. It's simply a first release, so we do expect that there will be issues that require us to intervene, taking some time and so on. However, next to this sponsored package, we also plan to set up a free tier, so that, because not everybody probably wants to do a small project directly, or really a larger investigation, and you just want to try some stuff. Therefore, we want to set up a free tier. This will be smaller in terms of the amount of credits that you can spend, and we want to launch it in the coming weeks or months, to even allow even more people on the platform after the first early adopters have started. On the forum, that's where you will be able to provide feedback. So this is the URL forum.openeo.cloud, and it's mostly at the beginning it will be for early adopters, so those will get access to the forum and see everything and be able to put their questions and feedback in there. Then there's also a message for another group of users. So you may also have a service or platform of your own. And basically, so it's not only about the 3 backends that are in there right now already. We also welcome those other platforms that might be thinking about setting up an OpenEO interface. Those could actually also become part of the platform. There's nothing concrete happening there right now, but if you're interested, please contact us. That would also be great to further extend the community and yeah, the capabilities of the whole setup. Thank you. Then I think Christian can wrap up.
Yeah, many thanks, Jeroen, also for mentioning how important it is for us to have early adapters around, really steering our developments and providing us feedback. Yeah, we are not there with a 99.999% service level, but we are aiming to improve that stepwise. And also for that, we also need your feedback. We need to learn what are the issues, well, how we can tackle them best. And yeah, and there's really the big invitation to join the community, to contribute, to provide feedback, also to contribute to the forum, and also to promote and also announce and publish new ideas and results around OpenEO platform. Yeah, with this, we are now at the end of the presentations and demos, and we are now entering the questions and answer session. The questions and answer session will be moderated by Alexander Jakob in Europe, sitting remotely there. Yeah, and with this, Alexander, I will hand over to you, and maybe you can just introduce.
Yeah, sure. Maybe you should unshare the screen on your device, because right now we have just a black screen here for everyone.
Yeah, that's true. So let's stop sharing and let's have you, Alex, in front.
Okay, yeah, great, thank you. So we saw a lot of nice presentations, lots and heaps of material. I hope it was interesting for all of you who are in the audience. We can be quite open here, so I think we set up this whole meeting in a way that everyone can talk and speak, so you can also just enable your video or your voice if you want to, like Günther just did, for example, popping up out here. But anyone else is also welcome. There were already a few questions asked in the chat. Maybe the first one that came already quite early was from Marcus during the first break regarding what the benefit of the Orfeo toolbox versus Snap is in the ARD generation, and that's maybe a good question to be answered by Jeroen, who has implemented that with his team.
Yes, indeed, and I had some time to think about it. It's actually just Orfeo supports fewer parameters, so not all possible variants of backscatter are supported by the Orfeo toolbox yet, but it actually is faster and more resource efficient. So that's why we went for it. So because we deployed it on Creo dies, and then we really wanted to have an option to get backscatter fast, even if we don't have all the number of parameters that we would like to have. But the setup with the Sentinel toolbox would require more processing time, and yeah, that would also need to be paid by our users, of course, through the credit system. That's basically the answer.
Hi, this is Marcus. Thanks for your answer. So would you have any ballpark figure on how much faster if we are dealing with the same equally large amount of data?
No, actually, a ballpark figure. We did measure it. I think we can process a Sentinel-2 tile, like 100 by 100 kilometer area, with Orfeo toolbox in a minute or less. It's that order of magnitude. Whereas, yeah, I think with the toolbox, it's slower, and the memory settings then are 0.5 gigabyte or less, so it's quite efficient. Whereas in my experience with the toolbox, we usually needed to configure it with a couple of gigabytes, and then the timing with the toolbox, if I remember well, was certainly more like 10 minutes or even longer, I think. But I have to be careful on that, of course. Depends. It's ballpark, let's say.
By the way, we have also the Snap processing available as an on-demand process. So it is also possible to use Snap for processing SAR backscatter within the OpenEO platform.
Do you have any recommendations, anyone, for Snap development if we would need to do something to, for example, enable the toolbox to work better on smaller chunks of input data or something of that sort?
Yeah, in general, that would help. I think for some processes in Snap that is already possible. So it really depends on the workflow that you're using. But in general, especially for cloud platforms, it really helps us if we can invoke processing on arbitrarily small areas. Usually we work like on chunks of, for example, 256 by 256 or something in that order of magnitude. Whereas a lot of processing software focuses on processing full products. And that is usually the problem with bringing it to a cloud environment that wants to be scalable. That is what we're always seeing when trying to integrate existing software. And there actually the Orfeo toolbox was quite good for that particular case.
Hey, thanks.
No problem. Over to Alex.
Thanks Jeroen for answering that question. Are there any other questions? I mean, there were some questions regarding the login procedures in the chat, but I think they have been answered also in the chat, and I think we saw this also in the presentations quite in detail, so I would not repeat that at this moment. But are there any other technical questions, any details about the architecture or even the use cases, the processes, the experiences so far, or other interesting questions from your side? Then please speak up and let us know.
People are still thinking, I can maybe add a sentence to the EGI check-in, because there was one question that the person couldn't find their identity provider, and in this case, if the organization you want to use to log in is not partnered with EGI and not available, you have at the bottom a small button, can't find your identity provider, and then it's of course also possible to just create a separate user account for this.
Yes, you can basically have an EGI SSO account, and then this one can be used for all this as well. Then you're not having the benefit of not needing to create yet another username and password, but still you can use the service. But at least for everyone who's part of the EduGain network, for example, so all of you who might using the EduRoam network, being there at the ESA right now, for example, you should be able to log in directly also with your credentials from that, or then the standard GitHub or LinkedIn accounts.
And a side note again on that is that it is not impossible if you're like the first person in your institution to ever log into EGI, that maybe your IT department needs to fix a few things here and there, because we do notice that if you're the first one trying it, there is some chance that it's not properly set up, the integration between your institution and EGI. But usually it's quite solvable.
Okay, now there's a question from Johan Karlstedt there about having the same data in multiple backends. How is this achieved? Is all the processed by one backend and copied to the rest, or is each backend producing it themselves? How do you ensure the data from each backend is the same?
Yeah, so there actually it works only for data sets that are the same to begin with. So for instance, Sentinel-2 level 1C, the level 2A collection from ESA processed with Send2Car. Those are collections that are simply mirrored already on different infrastructures. And that's where we want to do it. So it's not that, we process a collection and then mirror it ourselves. That's really the idea.
Exactly, and there's also still something for our future development, as Jeroen has pointed out, regarding the federation aspect of it, how to work in the distributed computing right now we have the very first part of the federation in terms of finding all the processes and all the data set that is around everywhere and being able to at least route requests towards where they can be fulfilled. So this is the first step of the federation. The next one will be also then to have a availability of loading data sets that have been pre-processed in one and sent them to another, which will be definitely a use case happening when we start splitting process graphs and send them into the different backends. The first partial solution of this is this load results function, which right now works within one backend, but in the future, the idea would be that this is also something where you can then push results from one backend to the other. This works a little bit like when you do spatial joins in a database, you try to do this as late as possible on as little as possible data, of course, so that you're not pushing around as much unnecessary large amounts of data. So you try to reduce as much as possible, and then you start to send around the intermediate results as on the smallest possible footprint, basically. Yeah, but it's still, let's say, under development and in design for this particular part. And yeah, the main duplication right now is really on the input data where it's already the same. And there it's already a big achievement to actually make sure that the same input data in the same backends is identified as being the same, because that, based on how metadata is organized, this really needs to be harmonized, and a lot of standardization is required there. And that's also one of the good reasons to adopt things like Stack and CEOS and Card4L in order to make sure that you're able identifying that you are comparing apples to apples with respect to what has been done to the data, because only then can you be sure that this actually is the same data when you continue there. Okay. Then we got some further comments on the login. Thanks, Valeria. You can also use your org ID credentials to log into EDI check-in and other socials. Thanks, Danius, for these comments. And then there's a next question from Lucas Bark, who is asking, what are the limits of UDFs? As I recall correctly, they're container spawned in the backend. So what happens when I download and process many polygons B-boxes simultaneously? Is there a cap to OpenEO connections? For example, loading training data via EO-Learn workflow. Very good question. That depends a lot on how the UDFs are implemented. I guess Jeroen can give a nice answer also to this, as they have already a different solution in place there.
Exactly. So for us, the UDFs are actually directly invoked. So it doesn't involve spawning a new container or whatever. The only thing is that sometimes we need to copy the data from the system that does the processing to the Python process that we spawn. So there is some overhead, but even there we are trying to further reduce that so that the UDFs can also be as efficient or close to being as efficient as native processes. That's at least what we want to achieve. On the other hand, we are also working very hard on, and that's a huge improvement we've done over the last 6 months, and it was visible a bit in the use cases, that you can do more without using UDFs. Like a year ago, you almost had to fall back to UDFs quite fast, and that is now much less already with the addition of quite a few processes. So we also hope to improve in that direction. And then actually the second part of the question is also interesting. It's about the number of connections you can make and if you want to load training data, right? And that's actually a problem we also came across when extracting training data for random forest. So we implemented support for that in the backend. So you can actually upload a GeoJSON with all your polygons for which you're looking for training data through the filter spatial method, it's called. And then you can instruct the backend to save small netcdf files for each polygon separately. And then you don't need to do this multi-connection thing and spamming the backend with, from 10 threads or whatever. It's just then the backend doing it for you, doing it internally, creating all these separate netcdf files with your training data. That's what I would recommend. Because if you would, I mean, you could try using the synchronous request for something like that, but you might end up overloading the backend and then indeed being blocked a bit or throttled to avoid that you overload the backend.
Generally, maybe as addition, also in the R for OpenEO project, we continue to look into UDFs and the improvements that can be done there, specifically also in the scenario where the UDF is written in one programming language that is not the same as the rest of the backend. And in the Jerome use case scenario, you have basically everything in a Python-based environment, and it's a little bit simpler as you can do in-memory handovers of data and so on. We are in the R case, we will also try to have a more efficient exchange format of the data that is sent between the main process line and then your UDF environment to improve this and reduce the overhead. Also there to have also mixed workflows possible where basically parts of your code could be written in R in a UDF and rest is running in a Python environment of the general backend for being processed and so on. So the UDFs gives us actually a lot of flexibility, but in this kind of mixed scenarios, there are certainly some limitations with respect to the size of what can be done. And as Jerome said, in the end, the final objective is to have really as little as possible UDFs and rely as much as possible on the predefined processes, as they are really the ones guaranteed to be scalable and running large scale, because they have all the backend specific optimizations in place, which of course with the UDFs there's some limit to what you can do in terms of optimizing them and some level of dependence on the user. Okay, that was a little bit discussion around the UDFs. Then we have another interesting question here regarding the extensibility of softwares that can be used in the platform. Specifically, the question was if Saga.js can be integrated in the platform. Any thoughts about this?
Yes, sorry, I didn't see the question myself yet, but yeah, this is closely related to what we were discussing before with Orfeo and so on. If the software has a nice interface, for instance, working with NumPy arrays and especially being able to work on a smaller area, then it's usually easier for us to integrate. If it's more like software that starts from a Sentinel-2 product and wants to process all of that, it's harder to put into a cloud environment. So it really requires investigation per toolbox, per type of software. How well that will work out.
Exactly. Maybe the more interesting question would be what are the kind of tools and features that the specific software offers you that you are missing from the platform, and understand if it's actually necessary to import another piece of software, or if we can just replicate the functionality in native OpenEO processes. That is also one thing to consider here, depending on the type of application. Regarding GIS, there's definitely already quite a lot of work being done by the folks at Mundialis, who have based their whole OpenEO backend on GrassJS. So a lot of functionality via the Actinia framework and GrassGIS is available in what they do. That's not yet in an OpenEO platform, but certainly something. The whole vector processing side is definitely something where we also need to think about how to become more functionality rich there. Okay, there's another issue from Alex Herr regarding the login. Maybe someone can have a look at the specific case. But yeah, as pointed out by Daniel, there is 2 steps. First, making sure that you're registered with EGI, and then second, registered to the virtual organization of OpenEO platform there. So there was a second question from Lucas. The doc state that you can decrypt the connection by stream when I do cube download to a TIFF. Can I directly put the cube in a NumPy array? And when yes, how? Because I re-imported everything via raster.io.
Yeah, I should have my code editor right now, right? Yes, it's possible, but I can't. It's a bit hard to immediately give you a code sample here. Basically, yeah, cube.download, if you don't specify a file name, it will give you the bytes, and raster.io indeed has the capability to read those bytes, and then you immediately get a NumPy array. That's the short answer. But yeah, I think we have some example of that already somewhere around in the notebooks. But maybe that would be a good one for the forum already.
Okay, another interesting question again from Johan Karlstedt is regarding if we can work with more than a single collection, and can we do data fusion in the platform? This is pretty simple to answer. That is yes. We showed some simple examples now where we just worked with individual collections, but there is actually a function that is called merge cubes, which can as input have several collections, and then you can make sure, you need, of course, when you work with different input data, that you work on the same feature domain and spatial or temporal domain. So this merge cube function has so-called overlap resolvers to make sure that you work on the same spatial grid, the same temporal grid and time axis, and you can then join different bands from different collections or completely different data sets, like the SAR data from Sentinel-1 and the multispectral data from Sentinel-2, or even for if you have a partial collection of Landsat and Sentinel-2, then you can try to integrate them into a continuous time series or something like this. All of these kind of things can be done. It's a little bit more complex, and we didn't show it in the examples here, but it's definitely possible.
Yeah. And actually, the crop classification use case does that. So it already has support for Sentinel-1. If you would click through to the actual notebook, you might be able to find a concrete example there.
Exactly. Michele also pointed out that in the notebook on the change detection, he did exactly this by having the cloud masks and the Sentinel-2 into different collections for doing the data fusion. Any more questions from the audience? I repeat, you can also just talk to us if you don't want to type and feel that's too cumbersome. As I said, I think everyone can unmute here and be able to talk if you have concrete questions. We're happy. Of course, we have this hybrid event there. I don't know if there are actually any more people in the hall than the ones.
No, actually,
okay.
It's a quite special event over here.
Yeah.
I had one more question about the apply UDF function. In the UDF, you always have the apply UDF function, and that then you can use Xarray, and it turns it back to a data queue. And I was thinking, because I don't know, you have one example where you're using a gun somehow on the NDVI, and you're planning on using a machine learning somewhat function. How would you do that? Like if you have a CNN which detects an object, and you just use OpenEO for a small area, and let's say there's a house in it, and then the CNN detects houses, and I just get back a yes or no, there is a house, or just a masked CNN which marks the house. Okay, this would work in an array because in a queue, but will that be limited to you always get back a data queue, or will there another function for like especially like a CNN or object detector? Or yes, will that be extended, or is it a limit?
Indeed. No, that's what we always try to do in these use cases. So we come up with new use cases, and very often they push the boundaries of the processes, and then sometimes we just define new processes and integrate them into the platform. So this is a very good example, actually. So indeed, if we don't have anything specified that returns something else than a data cube, then yes, you would need that. Although the UDF API, in fact, can also return more arbitrary JSON, and I believe that at Vito we've already tried that. So there are cases where we have gone a little bit further than only returning raster data, but it's certainly an advanced one that you're asking here. So I would have to check. But yeah, we really value this kind of feedback, like, oh, hey, I have this use case and I think it's not supported. And then we can start thinking like, okay, what do we need in terms of additional processes and whatnot. On the other hand, if you're mentioning the general AI and deep learning topic, it's one that we are very much aware of and want to go a bit further into. So we are also looking there for opportunities on how we can get deeper into that as well.
Exactly. I mean, generally the whole design of OpenEO is very extensible. So processes can be extended. You saw it also, backends can be extended. So the federation can be extended. The clients could even be extended. So right now we have R, Python, and JavaScript, but they all communicate through the API, and there's nothing from stopping to requesting. I don't know, I work in Scala or Julia or some other interface or programming languages. So you could also think about developing new clients if this is if you are a user and you have a very strict way of how you need to provide this to your community, then this is also something that in future can be thought about to extend this, because the API is really designed in a very architecture agnostic way to make all of these kind of ways possible. And that is both true for the client and the backend side, actually. So if someone has the will to put the labor in, then this can definitely be done, and that's why it's all open source and extendable. And I think, yeah, all of the implementations, even of the processes, you can find online to see how they're implemented right now. And of course, that can also shed some more details into all the specifics of how they actually run then in the specific backends, like the GeoTrellis backend or in the Dask and Xarray based processing world. So that's all extendable. Just a general remark there.
Okay, one more question.
Sure.
How much of the stack metadata is already implemented? I read that somewhere on the issues, like that you can, if you filter, use cloud cover, etc. How much of that is already in there, or is that coming?
For the filtering or for the, so you have it on the input side where you can use.
Yeah, when I do load collection and just say cloud cover, etc.
Yeah, exactly. So that case is implemented, if I'm correct. We also use it, for instance, to filter on a relative orbit or orbit direction in Sentinel-1. That's a typical use case. So yes, that is supported. But there, I mean, you do run into issues with also the different infrastructures having different properties. So again, a need for harmonization there to make sure that our users can just use orbit direction and it works everywhere. That's sometimes still a challenge. But again, something we do support, yeah.
But yeah, I mean, in general, I think we have pretty much the full stack metadata there. And yeah, with respect to the filtering, it's a work in progress. What is actually going through in the end, but quite some stuff is already possible. And yeah, as Jeroen said, the main effort is really this harmonizing how different backends that are part of the federation exposes this information and make sure that this then works seamlessly across the different backends. And that's where we started investing quite a lot of time most recently. The whole aggregator thing is relatively new to OpenEO. We started using it just a month ago, more or less. So there's definitely still some some more work to be done before this works perfect in all scenarios. But yeah, we still also have quite some project time left to bring all of these things up to speed. But it's definitely important, and also for the usefulness, very important. Of course, you want to be able to only work on the relevant data and filter for this before, and this also reduces processing time, processing cost, resources consumed, and so on. So we are well aware of this, and that's definitely in the works. Jonas from DLR proposes it would be good to have a standardized metadata set from Sentinel data provided by ESA ? So this is maybe something we can give to our colleagues from ESA here, what they think about this, but I think it's definitely a nice idea. Anyone who wants to respond to that?
I certainly vote for it.
No one from ESA to respond. Can you repeat? It was a standardized data set of Sentinel, or what?
The metadata, basically to standardize the way how ESA describes the metadata, and especially to also bring this into the world of STAC, so the Spatial Temporal Asset Catalog, which has most recently been developed into a kind of de facto standard for describing the geospatial
Excellent idea. You know it now, by end of the year, there will come the big data access ITT. For Copernicus will come out. And there will be an industry day on that in November. And who wants to do that? I'm happy if she is part of the offer to propose that in the industry proposal.
Okay.
Yeah, that's good to know. Hi, Jonas. Because I think that it's very much important to have also, we have a lot of mission-specific metadata. And I observed when going to different data providers that also, for example, for Sentinel-2, just the number of the Sentinel tile is put into different metadata properties. So it would be really great to have mission-specific, maybe stack extensions like Landsat is, or the USGS is also doing for Landsat. I think that's very much important.
Yeah, I think that's in general for the future a great idea. I mean, not for the level 1C data, but at least for the level 2A data, Matthias Moore has done some great work to provide this whole CEOS Card4L compliant stack extensions already. That's the first step in this direction, but of course it would be great if the original data one step before is also already following a kind of standard. Patrick comments that he believes also that the Sentinel-2 collection 1 will adopt stack after the reprocessing challenge has completed. So that's also good to know, and also a good step in the right direction.
New information for those who want to become a backend. Actually, yeah, nothing new. The first step is to actually be OpenEO compliant. So that's, yeah, the big thing there, of course. So you need to implement the standard. And once you have that, like on our side, we haven't done it before, right? So anyone who would be applying would be the first. So we are building also the federation in that manner on specifying, like, what do you need to be to join the platform. That's not very concrete yet, but really the first requirement is, yeah, implementing OpenEO and to a sufficient level that you add value to the platform, of course.
Yeah, and then generally, I would say also then, yeah, get further in touch with us. I mean, with Johan, we have already had a first meeting. There are other people. Jonas at DLR is also, for example, working on things in this direction. So if you're interested in this, then really, I think the next step would be to have some meetings and come up with a roadmap and things to do. That makes sense for everyone. But again, as Jerome said, makes sense for the platform as a federation and understand well what are the steps needed for the backend. Yeah. Okay. There's a next question. There are many ESA initiatives, EO, EP, CA, tabs with adapt the Eurodata Cube. Are these client-facing options to select for processing, or are they already planned to converge to become OpenEO backends? That's an interesting question. This is, I guess, depends on the different platform operators in which way they want to spin this, in which direction they want to further develop. The one where we have a concrete collaboration now is the Eurodata Cube, which is especially with the Sentinel Hub component very well integrated already into what we are currently doing. But there's definitely also there the potential to think about if it makes sense for a specific tab or any other existing platform to use OpenEO either by being integrated as a backend or by just operating the services using OpenEO as the way of implementing that. The latter is something which we are currently, as a first prototype, want to try in the Alpine region initiative, private EO for Alps project, and specifically the ecosystems one, where we work together with Solenix to try to see what we can do by implementing the services there, basically as on top of OpenEO platform partially. But yeah, for existing one, it depends how the software stack and the standards and interfaces that they are used, how well they are in line with what OpenEO is offering now. There will certainly be some more discussions now also between the different architecture designs, let's say, in ESA, and the working group has recently been established in this direction. Not sure how much we can already talk about this, so I can just say that there's some work going on to start thinking about how this can be done in a good way. There was again a question regarding the Sentinel-2 Collection 1 timeline, and that's definitely not something which has anything to do with OpenEO platform. I don't know if anyone wants to answer this other than...
Patrick already answered it.
Okay, sorry.
So the other question is about whether we want to include correlative ground-based data sources. My Cal-Val knowledge is a bit limited there. But I mean, yeah, raster data sources are already possible to integrate, but there are no concrete plans for anything specific. So it's really demand driven and user driven. So yeah, posting that question in the form or sending it by mail. Of course, maybe explaining what your use case is or how it would help you to make the platform better. That would be helpful, and then we can bundle all these requests and see how we can accommodate them. I see it's 5 to 5, so the questions also seem to be over.
if we have exhausted all the questions, there's no more burning question from your side, then I think we can close here. I'm very happy for your active participation in this Q&A session and also following along the whole afternoon to all the presentations. Thanks a lot for this, and I guess we have some closing remarks now from Christian then to officially close the session and the event and the public launch.
Yes, so we have prepared one final slide basically, and just to give you some closing remarks. Actually in a joint manner, Harun and I, so we keep distance, but nevertheless stand together within the closing of the session. Yeah, first of all, many thanks to all the participants. I think it was really a great number on this even late Friday afternoon to have all these people around, and I'm also very thankful about the very active participation. So I think it was, from my point of view, one of the greatest questions and answer sessions that I have seen in such an online setup, because we really had a lot of points there, and we really recognize that there's some interest into a lot of different directions. For sure, we cannot handle everything immediately, but as we mentioned initially, all these questions, all these remarks and comments we will consider, and will also guide us along the timeline of the project, and we try to address this as much as possible. But again, we invite you to actively contribute, and that's actually the first statement. So it's really, feedback is what we really value, and on the other hand, we also invite you to be part of the community. The software is open source, it's transparent, you can contribute, and we really invite you to be part of that. The forum is around, is established. We will first collect first experience with it, and hopefully this is also giving us additional momentum in developments and also in the feedback and interaction with the respective users. Yeah, so from my point of view, I'm really very happy about this participation. What you see on the slides is basically a summary on where you can follow on one hand on the website.
We don't see the slides if you have them.
Sorry. Oh, sorry. That I forgot. Thanks for that note. Now it should be visible. Yeah, so that's actually a slide about which I'm talking about really since 30 seconds or so. So that gives the links towards the website, towards the early adapter registration, and we really invite those interested to register there and to get also free credits to use OpenEO platform for 3 months. And if you're really active and show us that you do contribute in a good manner, then we are happy to extend this further. Yeah, there's also this Twitter account around and the link to the forum. We also have a contact point established for all email requests so that we can collect them. And last but not least, we also want to announce that the slides will be available also on the web page soon, so that people who contributed or who hadn't had the time also to get insights in what we did and what we presented here now in this side event of the Phiweek. Yeah, I think that's actually most of the points. I don't know, Harun, if you want to add some final word.
No, I think mostly that, yeah, I'm very happy that we made it to this release. I've been working on this for like 3 years, I think, together with the team at Vital, but also really a number of great consortium partners. And it's always fun when a software product or a platform like this can finally reach an actual audience of users that are hopefully looking forward to try it out and give feedback. So we're happy to be at this point.
Yeah, many thanks, and yeah, we're also happy to contribute, and thanks again to the whole audience. With this, we want to close today, but we stay in touch. We are here to reply to your requests and suggestions, and please contact us via these different possibilities. Thanks a lot, and I wish you a great Friday evening and also a great weekend, and let's continue the work on OpenEO platform. Thanks a lot.